Next question. Two samples M and N of slag lime were obtained from two different reactions. The details about their composition are as follows. Sample M, mass 7 gram, mass of constituent oxygen 2 gram, mass of constituent calcium is 5 gram, and second sample N contain N has 1.4 gram as its weight. Mass of constituent oxygen is 0.4 gram. Mass of constituent calcium is 1.0 gram. Which law of chemical combination does this prove? Explain. So two samples of slag lime. Slag lime has formula CaO, calcium oxide. Calcium oxide is also called as slag lime. So two samples of slag lime are taken and they are obtained from two different reactions. So sample M has weight 7 gram and it contains two constituent elements, oxygen and calcium. Oxygen has mass 2 gram and calcium has mass 5 gram. Similarly, in N gram, 0.4 gram of oxygen is present and 1.0 gram of calcium is present, and the sample N has mass 1.4 gram. Now the question is, which law of chemical combination does this prove, and explain it. Let us see the answer of this question. The atomic mass of calcium and oxygen is 40 and 16 respectively. So mass of calcium, atomic mass of calcium is 40 gram and oxygen has atomic mass 16. And this means the proportion by weight of the constituent elements calcium and oxygen in the compound CaO is 40 divided by 16. So the reduced ratio of 40 is to 16 is 5 is to 2. How it has been calculated? 40 and the number 40 and 16 are divisible by the number 8. So 40 divided by 8 is 5 and 16 divided by 8 is 2. So the ratio of 40 is to 16. Reduced ratio of 40 is to 16 is 5 is to 2. Now, for the given sample of M of CaO, it is given that it is 7 gram. Mass of constituent calcium is 5 gram and mass of constituent oxygen is 2 gram. Means 7 gram of calcium oxide contains 5 gram of calcium and 2 gram of oxygen, and therefore proportion by weight is 5 is to 2. So is it clear to you? When we calculate the ratio by considering atomic mass of calcium and oxygen, it comes to be 5 is to 2. And when the from the given sample, it is given that calcium has mass 5 gram and oxygen has mass 2 gram. So the ratio of calcium, mass of calcium and mass of oxygen is 5 is to 2. So does it match with calculated atomic mass of calcium and oxygen? Yes. Now second sample contains calcium 1 gram by mass and oxygen is present as 0.4 gram. Now if we divide 1 by 0.4, let us see. 1.4 gram of calcium oxide contains 1 gram of calcium and 0.4 gram of oxygen. So the proportion by weight is 1 divided by 0.4. Now if we remove the decimal point from denominator, the numerator will become 10 and 10 divided by 4. If we divide 10 and 4 both by common number 2, then you will get reduced ratio as 5 divided by 2, and that is nothing but 5 is to 2. This means the proportion by weight of constituent elements calcium and oxygen in different samples of calcium oxide is always constant. So in M sample we have got the ratio of calcium to oxygen as 5 is to 2, and in sample N also we have got the ratio of calcium to oxygen as 5 is to 2. So though the calcium oxide compound has been obtained from two different sources, the proportion by weight of the constituent element calcium and oxygen is always constant, and that is equal to 5:2. The experimental value of proportion by weight of constituent elements matched with the expected proportion calculated from the molecular formula. Thus, the law of constant proportion is verified. So, which law has been verified here? Law of constant proportion, because the experimental value is matched with calculated value, which is, and that calculated value comes from molecular formula. So both the values, experimental value and calculated value, here gets matched, and therefore the law of constant proportion is verified. We will discuss next question in next video.